Pong. This was the first video game ever made, and it's actually a pretty good project for your own first video game. So today we're going to go over how to make this in Unity. So here we have an entirely empty Unity project, and we're going to start with a couple of things. We're going to add some 2D objects in the form of sprites, and we're just going to add some squares because we're going to make some walls at the top and the bottom. And we're going to add a component to that, and we're going to add a box collider to this way we'll actually give this rectangle here some collision. We can just copy this one over and drag it down to the bottom of our screen. Then we're going to add two more sprites, and these ones are going to be the player and the opponent. So let's call this one player. Put it on the left side over here, copy it over and call it enemy, and put it over on the right side. Now we have our play field. Obviously these both need box colliders as well. Next we're going to need these scoring fields, because when the ball goes past either me or my opponent, we'll want the score to increase and the ball to reset to its original position and launch again. Luckily, this is relatively easy as well. We just keep adding more squares to this entire thing. These ones will be off screen. And when we add our box collider 2D to these, we're actually going to set these ones to is trigger. This way it will allow objects to pass through it, so nothing will bounce off it. But we can still trigger events through that, such as increasing the score, which is what we want here. So we're going to copy that over and put one over on the other side of the playfield as well. And we'll just give them some names like my score net, enemy score net. And let's add the ball as well. So we're going to add a circle sprite here, which we're going to put... I'm going to put it here for now because these icons are kind of in the way, and we're going to call that ball. Okay, so now if we go into the game, you will see absolutely nothing happens because we haven't programmed anything. And before we forget it, we also want to add a collider for the circle so that we can actually collide with it. First thing we're going to do is we're going to give our player character some movement. So we're going to add a component and we're going to add a new script. So let's call it player movement, create and add. In order for the player to be able to move around though, we're going to need to give it a rigid body. So we're also going to add a rigid body 2D. We will not be using any gravity, so set the gravity scale to 0. And while we're at it, we might as well give a rigid body 2D to the ball and the opponent as well, because they are going to need it too. Both of which are going to be set to gravity scale 0. Then when we double click this player movement over here, we will get a Visual Studio opening up. This is where we're going to make our script. So before anything else, we're going to make a float variable, and we're going to call that player speed. And by default, we can set it to 5. And we'll also add a rigid body 2D and call it RB. In our start function, we're going to give RB the value of getComponent rigid body 2D. This will just look in the game object this script is attached to, whether or not there is a rigid body 2D component, which there is, and then assign that specific component to this variable. So now in the update function, we can say RB velocity equals new vector2, and we'll say RB velocity x can stay the same, but we'll actually get rid of the RB velocity y, because for that we're going to get input, get axis raw, and we're going to put in vertical with a capital V. That is very, very important. But that's not quite everything there is to it. We're also going to multiply that by our player speed variable. So what this does is it will change the velocity the speed at which this object is moving and in what direction it's moving, to a new vector2, that's just a variable that holds two values, where the x velocity will be the same as the x velocity it has now, which should always be 0. And the y velocity will be equal to our getAxisRaw input, which is something that Unity comes with. It's mapped to the up and down arrows and the W and S key and things like analog sticks and controllers. It's just by default prepared for you. But that will only give us a speed of -1 to +1, which is a very slow moving speed. That's why we have this player speed variable, so that we can actually move faster. We can see we can move up and down and the walls stop us because we have collision. Now let's get to making the script for the ball, because that one also is very easy. So let's make a new component here and call it just ball movement. We'll open that up by double clicking that as well. And here we're going to do the same thing. So we're going to make a float for speed, which we're going to also set to 5 for the time being. We're going to add the rigid body 2D, which we're going to call RB as well. And then we also make a vector2 and we'll call that start position. This way we can keep track of where the ball starts during our game time. So we'll set our start position first. So we can say start position equals transform.position. It is pretty good at predicting what we want. Then just like before, we set the rigid body to get component rigid body 2D. And then we're going to make our own new function. We can get rid of the update function. We're not going to be using that. But instead we're going to make our own public void launch function. So now that we've made this, we can add that in here, launch. And any code that we put into these brackets here will get executed every time the game starts. Also every time another object tells this ball, hey, do your launch thing. You know what launching is, I have no idea what it actually means. I just know that I can tell you to launch and then it will execute the code within here. And we're going to be making an integer for x and we're going to be making an integer for y. And both of those are going to be equal to random.range. And the range is going to be 0 and 2. It just picks a random integer between 0 and 2. This is exclusive, so can't actually choose the upper one. What that effectively means is random range 0 to 2 means it will pick either 0 or 1. And we're going to do the same thing for y. Then we'll make a quick if statement where we'll check if x is equal to 0. We're going to do something, and that is set x to be equal to -1. And if it's not equal to 0, it must then logically be equal to 1, so we don't have to change it around. And then we'll also do the same thing. So if y is equals to 0, y then becomes -1. The reason we don't pick something in a range from -1 to +1 is because then it also has the chance of picking 0, at which point the ball will not move at all. Then finally we can set the RB velocity to being a new vector2 with x and y both again multiplied by the speed variable. So now if we start the game, this should shoot off in one of 4 directions. Diagonally up in one of the directions, diagonally down in one of the directions, but you can see this is definitely not quite finished yet, right? But it launches off in one of 4 random directions. So if we go in it again now, it should, random means that there can be repeat in sequences, but eventually it should launch in a different direction. So it can launch in any of those 4 directions. But as you could see, it wasn't particularly bouncy. And there is a very easy way to fix that. Because if we go over to the rigid body 2D here, we'll find that you can set a material. This is not a material like textures. This is a material that tells the rigid body how it should behave. So we can right click and create a new 2D physics material 2D. and we'll just call that ball. And we can set the friction to being 0 and the bounciness to being 1. Then if we drag this over to our material section here, it will become bouncy. But you also could see that the player, it started rotating around and stuff when the ball hit it. We don't really want that to happen. So in the rigid body for our player, we can go down here into constraints and we can say freeze rotation, and we can also freeze its X position. We're actually going to want to freeze rotation for all of these objects. And obviously the opponent is also going to be locked down into its X position. So now if we start playing the game again, we will see that it's much more recognizable already as being a Pong game. The only issue being is that the opponent doesn't really play. And we don't have any score yet. Let's take care of having the opponent playing against us, because that's the most fun part of this, right? So let's make a new script and call it enemy movement. And once again, when we double click it, it will open up in Visual Studio. We're going to start off by making a game object variable, and we'll just call that ball. The issue is, how do we put a value on this? Because unlike what we did here, where we got component from the game object we were in with this script, this is an entirely different game object, and we can't really use a simple line of code like that to just find something within the game object. Well, we could, but it's not good practice. So what we're going to do instead is we're going to put 2 square brackets there, and within that we're going to put the word serialize field. This will allow us, when we're back in the engine, you will see we have a little field here called ball, saying no game object selected, and drag this ball over here. And now this object knows it's referencing this ball whenever we use that variable in our code. And then obviously we do the same thing again, because we want to have a rigid body here that we're going to call rigid body. And we'll have a float for the speed. We'll put that equal to 5. You could very much put the serialized field in front of the speed variables for all of these objects as well, so that within the editor you can tweak around with what speed works. You can change those live during gameplay and you'll immediately see the effect. So you can tweak around with those very quickly and easily. Now in our update function, we're going to put an if statement, and we're going to check if ball.transform.position.y is greater than our own transform position y. We're going to change our rigid body velocity to being a new factor 2. Rigid body x can stay the same, but y is going to be equal to our speed. Else, if, you will see that it's trying to predict what we're trying to do here, and it's actually mistaken, because we don't really want to check it against the velocity. But we do want to have the ball transform position y. We do want to check whether or not it's smaller, but we want to check it against our own transform position y. Again, curly brackets. And if that's the case, we can just copy over this piece of code here. We want to set it to our speed variable, but negative, just negative speed works. If it's neither higher nor lower, it means we're exactly on par with where the ball is. So we're going to put another else in, and we'll set rigid body velocity to just being 0. So a quick recap here is we first put in the value for the game object that our ball will be. We put in our rigid body, which obviously, I almost forgot about that. We need to give a value. We set the speed to being 5. Then every single frame we're going to check, is that ball in a higher Y position than we are at the moment? If so, we're going to set our velocity to being upward. If it's at a lower Y position than the enemy is, it's going to set its velocity to being negative, so going down. If it's neither higher nor lower, which will effectively never happen, but it could, it will just set it to being 0. Now if we play the game, we should have a somewhat good AI actually playing against us. This AI will react instantly and should be damn near unbeatable. But that does bring us to the next point, and that is when the ball goes outside the playing field, the game just kind of stops, right? There's nothing else to do. And that's because these two things are going to need some scripts to keep score. So let's add our score counters real quick. We can add a UI, Text Mesh Pro, and it will add a canvas for you automatically. So we call this player points. And then if we double click on this canvas, we'll zoom out all the way and we'll see our Text Mesh Pro object over here. This is slightly annoying the way it works because you can't just do it based on your camera view. It gives you this UI canvas and you need to mess around with it a little bit yourself. You'll also likely need to import the Text Mesh Pro essentials for this to actually work. And then examples and extras, suppose can't hurt, right? So then all of this is your standard graphic design stuff. So we'll just center and center so that we have a centered 0 over here. I'm not too interested in making it look good at the moment. We're just going to add a component and call this score counter. You know the basic idea by now. Double click the score counter. And we're actually going to be adding something to the top of this using list. This is telling the engine, hey, we're using this and this and this part of specific libraries. Because otherwise, for every class, it would load in everything. And we don't, for instance, need AI here. So why would it load in all the functions that AI uses if we're not going to be using those? So we have to manually tell this we're going to be using TM Pro, which is Text Mesh Pro. And then we can add a Text Mesh Pro UGUI. And we'll just call this Text Mesh. We'll give that the proper value. And we're going to be adding a public integer, which means that any object referring to this script can access this. Things like this Text Mesh Pro and all the other variables we've made so far, nobody can access it other than the script itself. When we say public, other scripts can reference it, read it, but also change it. And we'll call it score. You'll also note that if we go back to the Unity editor, public variables, much like serialized fields, show up in the editor here. The difference is that a serialized field is only visible in your editor and can't be changed by other scripts, where a public variable can be. And really the only thing we need to do here is we need to say text mesh.text equals score to string. So we can put these points over here. We'll call this enemy points. And now let's get back to our playfield. Finally add the scoring mechanic, right? So we're going to add a component here and call it something like scoreNet. Just something that will count our score. Double click it to open it up. And now we can actually say score counter, which is a class we just made. If you make a specific class, you can reference that as a variable and then fill that in. So we've made a score counter and we'll just call that score counter. Why not? And we're going to make that a serialized field because we want to be able to fill it in within the editor. So this way we can use the script on a different game object that we have made in this game object and have them talk to each other. Now, we actually don't need the start function here or the update function. Everything we need is a onTriggerEnter2D, where we will go into our score counter. We'll get the score variable from there and we'll just say plus plus, which means that it will increment it by 1, which is this score variable, which is being displayed through this bit of code over here. But then we also need to reset the ball. So we can say ball movement and just call this one ball, which again, we're going to make this a serialized field just to keep things simple for the time being. And after we increase the score, we're going to set ball.transform.position. It's going to be equal to ball dot. And now we run into something because we didn't make the start position for the ball public. So we can't actually read it. So we need to make this public. And then we can say start position. So it will reset its position for the ball back to where it started at. And then we can say ball.launch, which is the function we made before, remember? In the ball movement, we made our own function here that launches in a random direction. So now when we enter the trigger zone, which the collision we've given this object is a trigger box, not a collision box. Slight difference there. So when the ball enters this, we'll increase the score of the referenced score counter script. We'll change the position from the ball back to its starting position. And we'll tell the ball launch in a random direction again. So we can now see a score counter, which means that when the ball hits this, the enemy scores. So we can just drag over this to the score counter. It'll automatically pick the right scripts on that object, which is very, very nice. And then we also can say the ball is this one. Drag it over there. Then on the other side, since we now have a scoreNet component, we can just add that and tell it this is for the player points and the ball is obviously still the ball. So now if the enemy scores a point, we'll see he gets a point, and again it's going to be relatively difficult for me to get a point because these things are moving at the exact same speed. But that's Pong. We've made Pong. You have now made Pong. You are a game developer now. You've made a game.